All right, number 11, home stretch here, guys. This is one of the most polarizing problems on the test, okay? And you'll see what I mean. First off, I look at it and I think, oh, great, maybe we square root method this, but can't do a square root method when there's an x term, okay? So that's out the window. I like the easy methods. I look to see if I can use those, but I can't use that one here, okay? Then I look and say, okay, what's a different way to do it? And what really jumps out in my mind is the type that always works, the quadratic formula. It just always works, okay? There's only a few rare occurrences that doesn't, and we don't really work with those because they're not quadratics anyways. So what I think when I see this is I go, okay, probably just gonna have to square or quadratic formula this. Probably gonna have to do it. And that's okay. A equals 9, B equals 36, that's a huge number, and C equals 0. Let's get down to the quadratic formula. Being negative b, which is negative of a positive is negative, negative 36 plus or minus square root 36 squared minus 4 times a, which is 9, times c, which is 0, over 2a, which is 2 times 9. Okay? Keep on carrying on. Let's see. Let's talk about what's under the radical. Let's talk about the discriminant. Well, it's going to be 36 squared. It's a huge number. Minus 49 times 0, or 4 times 9 times 0. Okay, that's going to be 36 times 0. That's just going to be 0, meaning that piece is gone. The only thing under the radical here is 36 squared. I don't know about y'all, but my times tables didn't really go up that high. So I'd move on over into Desmos and see what 36 squared is. Ooh, big number, 1,296. Okay, well, I know that's under the radical. So just on a whim, let's see. What's the square root of 1,296? Oh, it's a perfect 36. How'd that happen? Oh, well, because the only thing left under the radical, the only thing left in the discriminant was a perfect square after all. So we know that whole discriminant, when we square root it, will just be positive 36. Okay. Now, if you were to type this whole thing, everything in the under the discriminant in, you'll see it ends up being the same thing. That was 36 squared. Need parentheses around that, but it's not negative, so that's okay. Let's put them though. Minus 4 times 9 times 0. This is if you typed everything in. And look, like I said, it gives you the same exact answer because this is just 0. So under the radical, we had 1,296, but that perfectly squared or square rooted into 36. So our new problem, negative 36 plus or minus 36 over 18. Okay, because 2 times 9 is 18. I had some emails the first day saying, where'd you get that number? I'm just multiplying those together. Okay, I probably should have elaborated on that a little bit. Now, the next thing is a lot of people get tripped up here. They'll sit there and say, oh, that just makes 0, Mr. O. Those cancel out. Well, sometimes they do, but sometimes they don't. Remember, this is where our problem splits. Negative 36 plus 36 over 18. And the other half, negative 36 minus 36 over 18. That's the plus or minus split. We get a plus sign on one, a minus sign on the other. So on the left-hand side, those do cancel out. Negative 36 and positive 36 cancel out to be 0 over 18. 0 divided by anything is just 0. On the left-hand side, we get a negative 72 over 18. And again, if you're really good with your multiplications and being creative and doing that kind of stuff in your head, that's fine. If not, pop on over into the calculator. Okay, let's go drop down a line. Negative 72 divided by 18 is negative 4. So our two results we should get are that x equals 0 and x equals negative 4. Really, in a perfect world, I should have been carrying those x's along with us the whole time. Okay? Tough problem. A lot of difficult stuff there. Be careful. The other way to do this problem, and this is why I said it'd be polarizing, is you can actually factor this and solve. Now, remember what our zeros were. We should have had a 0 and a negative 4 as our final answers. And briefly, I want to show you the factoring way to do this. First step of factoring is to get out a GCF. I can take a 9x out of the entire thing. When I do that, 9 divided by 9 is 1, x taken away is leaving a single x. Plus 36 divided by 9 is 4. I had one x here, I took it away. It's just been a long time since we've done this, so I think a lot of people will probably steer clear from this and do it with quadratic formula. Now, if you remember, what we did is after we factored, we set both pieces equal to 0. That means we have 9x equals 0 and x plus 4 equals 0. If I divide by 9, again, 0 divided by anything is just 0. Over here, though, I have to subtract 4 and subtract 4. When I do that, I get that x equals -4. So again, same exact answers we did, a lot faster. And some of you are going to look and go, why'd you even show us the hard way? You said you were a lazy man. I am. But if the quadratic formula works all the time, it's a pretty good method to be very, very used to. Okay. This weird factoring and set both sides equals, we did a lot, but mostly with binomials. We didn't do it a whole lot with problems like this that were odd GCF factor type problems. So that's something to keep in the toolbox, though, an idea to keep with you.